So now this is our lab. I'm going to be showing you how we come across, we're able to go to those plots. You will actually use base R to build those plots, but it's encouraged to use the ggplot2 package when you are trying to plot in as a biostatistician trying to plot, because it's more easy and it's based on the layer of graphics. I'm going to be showing you now how the ggplot2 package actually works, and you could check more about ggplot2. I explained more about it inside one of my course, exploratory data analysis with R. So first of all, you have to have the ggplot2 package. If you don't have it, ensure you install it. You install it like this. So ensure you install it. I already have it, so that I'm not going to be installing it. Use the install.packages function. Then first of all, let's load it. I'm going to be loading it using the library ggplot2, and I'm going to be using the check weights, which is actually available on R by default. And we're going to create an histogram. So the ggplot2 actually has a main function. This is it, ggplot. So ggplot, if I should just cut this and call this, I'm going to get an empty graph. So you can see I'm getting an empty graph in this particular place. So because the ggplot2 works on the layer of graphics, this ggplot function takes your data, which is check weight, and after taking your data, you are going to provide another argument called aesthetics. Inside this aesthetics argument is where you are going to signify your x and y axis. So your x-axis is actually weight. We don't have a y-axis because we are plotting an histogram. We don't need to declare a y-axis because we are plotting an histogram, which is going to be calculated for us. That is, the y-axis will be calculated for us, which is the frequency. So now I'm going to paste this back. I'm going to paste this back, and you can see that is our first layer. That is where we got this particular empty plot. You can see the weight. If I should remove this now, I'm coming, and I just code this like this. You can see I get an empty graph because I'm not signifying what my x-axis is. So now I'm going to now remove this particular layer. Now I'm left with these two layers. Now we have various functions for plotting in ggplot2. For histogram, it's called geom histogram. You could check the function to learn more about the argument it takes. First of all, one of the arguments it has is bin width, which are going to signify as 20. You could change that value, and we also have the fill, which is the fill, and we have the color, which is black. So if I should clear all of this now, and just, you can see I just have a boring looking plot without color. Now let's say I now remove the fill and just leave only the color. You can see I'm just having it, but there is no outline signifying the bars. Then if I now say the color is black, which is the outline, then you can see I have now the outline for each particular bar inside the histogram. So now we have the next one, which is the lapse. The lapse function allows you to be able to signify your title, the labels. This lapse means labels, your title, the name of your x-axis, and the name of your y-axis. If I don't have this, you're going to see that it's just going to give me the variable name, and sometimes this variable name will not be what I want. Somebody can ask, what measurement are you using? So this is where I can signify it clearly. I'm just going to do like this now, and you can see. And if I come back here and run this, and just remove this, you can see I have it, the preferred labels I want. Now this team minimal doesn't mean anything. It's just your team. ggplot2 has various teams, and you can actually search on that online. So this team minimal is just used, so it doesn't have any significance in the plot. It's just your team that you want. You can actually remove it or choose to keep it. Now we also have the bar charts. I'm going to be loading another data set called dplier. So why I'm loading the dplier is because I need this particular symbol, and I'm going to be explaining how we are going to be using this symbol. Could check my course exploratory data analysis with R. I explained more details on this particular symbol. Data mslip, I'm going to be using the mslip data, and I'm going to be using the dplier. So just install it the way I showed you how to install other libraries, and I'm also going to load the data mslip. So this is actually called the pipe operator, and sometimes you could also use this. Like now you could see me using this. This is what it is by default. But earlier on when I wrote this code, this was what I used. They are both the same thing. Don't get confused. You can see actually combine them in this particular place. So don't get confused. Anywhere you see this, they are both working the same thing. And what they are used to do, they are used to chain a function. Let's say I want to get the mean of a vector, or let me put it like this now. Look at this. This is the simplest example I can give you. I can use this view function msleep to view my data in another window, right? You can see I can use it to view my data in another window. Why don't I now do like this? Instead of using the view function, I could just say msleep, then shift control M, then view. I still get the same thing, right? Now, this has already changed this particular this variable inside this function. So this is how the pipe operator works. Let's say I have a function D and I'm applying it on the variable X. That is the name of my variable. And I want to apply it again on another function, which is C. And I want to apply all of them on another function, which is B. And I want to apply it on another function, A. So you can see that it's somehow looking messy. So to avoid this, that was why this pipe operator was created. So with the pipe operator, I could just say X, pipe it to D. Don't forget that X is not a function, but the next items are going to be piping they are going to be functions. We pipe it to function D, pipe it to function C, pipe it to function B, and pipe it to function E. You can see it looks neat. Anybody that sees it knows that, okay, X is actually the main variable piped to function D. The result is now piped to C, which is piped to B and piped to A. So this avoids messy situation like this, or where you just say D of X, you call it another variable. Let's say you call it S. Then now say, okay, I'm now going to be applying S, the function C on S, and I'll now call this another variable. I can just devise to call it R. So these are just ways of making your work messy, and it doesn't make it interesting. That is why we have the pipe operator. Okay, back to what we are doing earlier on. Create a summary of the sleep time by order. We are trying to create a bar plot now. But first of all, if you look at, we have to create a summary table. That is why you see I have this code. Now, this is my msleep. If you want to understand more on the dplyr package, you could check the dplyr documentation. Also go to my course, Explanatory Data Analysis with R. I talked deeply about this particular dplyr package. So msleep, we pipe to group by order. If you look at my msleep now, let me just say add to just take the top 5 rows of the msleep. We have what we call order. This is the order of that each particular animal. Which order do they belong to? Biological order. So we're going to group by biological order. We're going to group each animal by biological order. That is why you can see it. So let me run it in this place separately. msleep group by order. When I run it now, it's going to group it, but nothing has been applied. We just grouped it. We just told it that it should group. So we need to create a summary. And what are we creating? We are trying to create the average sleep, which is the mean of the sleep total of each particular animal. And we're also telling you to what? Remove missing values if there are missing values. So don't add missing values to what we want. So this should be summarized. Then I'm going to run this. So you can see I've created another table. This is the order and this is the average sleep for each order. Now I'm going to plot a bar plot to show me the top average sleep. Top 5 average sleep. So now this is it. And now I have top 5 here, which means that because you can see this much, I just want the top 5. So I'm going to say top n. This top n means show me the top 5 data. It's going to order it and show me the top 5. And I'm going to run this. You can see this is my top 5. I can now call it sleep summary. So let me just remove this. And so I've already created a variable now called sleep summary. Now I now want to create a bar chart for it. So I've already explained to you. So the new thing here is just this field. We have another argument called field, which goes to order, which you can put inside your aesthetics. So what this does is that, unlike the one we did earlier on, which fills by the color, this one is going to fill by the order. You'll see what I mean by that now. First of all, let me just remove this and just run this. Now you can see nothing was created. Our bar was not created. We only have the axis created. Now we're going to be using geom bar identity. So stat is equal to identity. This is what you use when you want to create a bar plot. So you can see it has already created a bar plot. Now if I remove this field by order, what happens? It's not going to color the bar. So what I just told you to do by giving field by order in the aesthetic function is that it should fill each particular bar separately from different category. So give each of these category distinct colors. So that is what I just told you to do. Now I'll just give a theme minimal. So most of these are just customizations. But it's always a good practice to make your graph visually appealing by making it sorted. So I'm going to sort this particular graph now. You already understand the lapse function already. So now if you notice something now, I could just view this again. If you are not seeing it clearly, just open it, zoom. So you can see it now. It's already what's coming out clearly. The names are not packed together. And if you want it, if you don't want the names packed together, I actually put something here called theme. So it's going to shift. This argument is meant to shift the axis.text.x. So these elements are going to make it slanted, the angle at 45, and adjust it by 1. So that is why you can see it's already slanted like this. So it just depends what you want. These are things, various things I can actually look up in the documentation of ggplot2. Then next we have the box plot. I'm going to be using the tooth growth data, just like I showed you earlier on the slide. So we run this. So when you run the tooth growth data, you already have it. Then this should not be new to you. All of these are not new to you. So we are going to be using x-axis as supplements. Let us view the tooth growth data. So the length, supplements, and those. So I'm going to be using the supplements as this is the top 5. That's why I'm using the head function. This supplement is going to be my category. Length of the tooth is going to be my y-axis, which is continuous, and the fill, the color we're going to be using, is going to we need to have distinct box plots. It's going to be by the supplement. And we have the geom box plot function, which is used for creating box plots. We have your labels, and you run this. So you can see we have our particular box plot. So this is how you can create the box plots. For the pie charts also, the pie chart now, I just have a simple data frame which I created, diagnosis. So this diagnosis now is just counts: hypertension, diabetes, asthma, arthritis, and depression. This is the counts of number of patients having this particular diagnosis. Then I'm going to now calculate the percentage. So we can just calculate the percentage manually. So diagnosis counts, each of these divided by the total, which is the sum of the diagnosis counts times 100. So when I run this now, and I run my diagnosis data, you can see I have the percentage. So since I have this, I can now plot my pie chart. First of all, use your ggplot function. You give in your diagnosis argument and give you your aesthetics. We are just dealing with the y value, which is the count, and we want to give it a distinct fill. So the fill is going to be a condition. So this is our x-axis. We are not giving it, we don't have any variable for our x-axis, but we actually have for our y, which is the count. So the y is going to be the count. Now if you look at this, let's cut the whole of this and we run this. What do we have? You can see the x doesn't have a variable, but the y has a axis, which is counts. Then we're now going to plot a geom bar. So the reason why we're plotting a bar is like we're converting that particular bar into a pie chart. So this is how the bar is going to look like. Just only the count you can see. just the count. So you can use any of the variable you want, either count or percentage, depending on what you actually want, but it's just still the same thing. Now we now have cohort polar. The cohort polar now converts it now into a pie chart, as you are looking at it, a circular plot. So this is how it is going to happen. This is how the pie chart is being created. Then you look at the cohort polar function. You can see the polar coordinate system is mostly used for pie charts. So we usually use this to create a pie chart. So now the next thing now is now to give your labels, and this is just the team. We are giving it a team and the team legend position, and this is geom text to try and signify the percentage. So if we run all of this now, you can see that we have the pie chart. So what this geom text actually does is allows you to place this text inside the pie chart. And here you have the aesthetics function, which you can use in the geom text, and your label takes the value that you want to appear. So use this printf function to actually combine your variable, which is percentage, that percentage column we created earlier on, and you now signify to how many significant figures are you approximating it to, which is 1 significant figures. So you can check more on this printf function to learn more. I also have the position. So this various position, if I should give a position of 1 now, if I give a position of 1, you can see it has already shifted. So 0.5 allows it to appear more neatly on the pie chart. So if you the higher the value, let's say 5, you can see the higher the value, the scattered it is. So 0.5 is actually the point I was able to get to be able to place these particular values accurately in each of their respective pie. You can see to create a pie chart, you need to have a geom bar, but without an x-axis, which is your categories, and the fill is going to be by condition. If I remove the fill now, what do you think I will have? So you can see I don't have any pie chart that is being colored. So that fill variable is very important, because this is more or less like what shows the category of the pie chart. So now we have the scatter plot. The scatter plots are going to be using the mass library. I think this is actually available from base R. They use the birthweight data set, and just like we've been doing earlier on, your ggplot function takes in your birthweight, the aesthetics function takes in your x and y axis. So this is the birthweight. Your aesthetic function takes in the mother's birthweight, which is LWT, and baby's birthweight, which is BWT. Then you use this plus to add this layer, which is the geom point, where the alpha value is 0.6. Then use this plus to add your labels, then your team minimal. So just to change your team, and if you run this now, you can see we have a nicely looking scatter plot. So we're going to plot in a line graph. We're going to make use of the air passengers data from the zoo library. So we make sure we load the zoo library, and after doing that, we load the air passengers data set. So I'm not going to be viewing this because it's in a format that is not in a tabular format, but just know that it's somehow you can actually handle it like a data frame. So I'm going to be converting these air passengers into a data frame. So first of all, now I'm going to convert the dates inside this particular. It's actually in a time series format. That's a very complex format. It's beyond the scope of this course. So I'm just going to be converting the time to date, and convert the passengers to vector, and I'm going to load this because it's in a time series format. So when I say head df, you can see I'm actually having the number of passengers for that particular day. Now, just like you have done earlier on, use the ggplot2 function to signify your data. You're giving your aesthetics, where x is equals to date and y is equals to passengers. The geom line is going to be the line that you're trying to plot. This is the function for creating a line plot, and you're going to be giving it color of red. You're giving your labels and your team. This is very easy, and you get your line plot. Then we have the frequency polygon. So the frequency polygon, you have to load your ggplot2 package, also your tooth growth. You make sure you load them, and we are going to use the ggplot function. you give in your data first, then your aesthetics. So the frequency polygon, we just need only the x-axis, which is length. So if I should just give this, then I'm going to be using the geom frequency poly function, which works similar to the geom histogram function. So, but this time I'm going to plot a frequency polygon. I'll signify the bin width, which is actually 2, and give it a color of blue. Then I'll add my labels. So when I run this now, you can see I'm having my frequency polygon. If I change the bin width to 5, I already explained the bin width. You have something like this. If you want to create your histogram with frequency polygon now, so you want to create an histogram, you want to show the frequency polygon on the histogram. So this is how you also do it. But this time around, I'm just going to be combining your geom histogram and geom frequency poly. So let's just say I remove this now. So you can see I have a geom histogram. So I've combined the geom histogram function inside the first layer. The second layer is the geom frequency, and I've added my labels. So the reason why you see we're having the density here, because we are trying to plot an histogram with the frequency polygon, and we are no more going to be using the frequency. We are no more going to be using the frequency y-axis. We are going to be using the density. Now this density shows us how dense that particular point is. So that's why I can see we're using y is equal to after start density. So this is the labels. This is our team minimal. We will have signifying the bin width, the fill. As you can see, the fill of the histogram is light blue. That of the frequency polygon is red. You can see the color also is black. The color of the outline is black. So these are the various ways you can use to create various plots in R using ggplot2. If you want to learn more, I advise you check out the ggplot2 documentation. With this knowledge you have now, you can understand documentation and explore various ways of plotting other visualizations using other functions you see in the documentation.